All right, exciting to be here. So, yeah, I'm going to be chatting about something that me and kind of my team has been working on since pretty much 2015 when we started thinking about like user identity in crypto. And really, what we figured out is identity isn't just like something that's a credential or a verification that you get from an institution or a government. It's more kind of like an emergent property from all of the interactions with other people in the world. And in order to kind of capture all of those interactions, that needs to happen in a kind of, we need data about them. And we want this data to be publicly verifiable, of course, if we want to build kind of decentralized applications. So today I'm going to be talking about the internet's user table and basically how we can build a database and a user network that we can eventually outcompete any kind of incumbent big tech company. All right, so what's a user table? Well, it's essentially just this kind of database that contains like user information. So you might have an identifier for a user, you might store a password hash, and you might store some other information like a username and whatnot. And this can be used to identify the user if they sign into your backend, or to store any type of like data associated with the user, or like posts that the user made to like interact with other users. And so as a company that, you know, building a Web 2 system, you kind of have the incentive to create a large user table as possible, because then you get kind of network effects. And that's kind of how you win the Web 2 game. You have a proprietary user table that logs people into your application. But what that kind of game and competition eventually creates is something that looks like this. You have these big companies that have huge silos of user table data or like user data, and they end up using that in their position to extract as much value from the users as possible without kind of any regard for externalities on the users or the communities that the users exist in. And really kind of what we want to create in Web3 and with the technology we're all building is something more like this. We have kind of like an open ecosystem of data where users have full kind of control and sovereignty over it. And different applications can kind of mix and match, and you have this kind of modular architecture. And so I thought this kind of solar punk inspired image kind of describes that, or like visualizes that pretty well. All right, so how do we do this? Well, actually, I missed a slide. So doesn't like blockchain applications kind of solve this today? Well, the problem is you have a user wallet and you use that to interact with smart contracts. And on the kind of financial layer, you have mostly like this type of interoperability between users, because any app can kind of create a front end for the smart contracts. But most kind of more sophisticated dApps today that kind of have more social features and stuff like that, they actually store their user data on a backend and a centralized user table. You might sign in with the wallet, we still have the kind of same siloing effect of data. And so how do we solve this? Well, we need to create a global shared user table where all applications can kind of like store data that's with the user. The user has full control and can choose which application kind of get access. And eventually, essentially like let the applications build networks effects together. And so what would this look like? Well, maybe something like this. So in this kind of stupid example, you have like an Ethereum address that cryptographically signs any updates to the columns here, which is username and emoji. And this could potentially be a way to represent like any user. Well, there are some problems with this though. Firstly, we kind of need a better way to represent the user than like an Ethereum address. There are many blockchains, so we definitely want, you know, a user to be able to use different accounts that they have on different blockchains. So they want to be able to link their Filecoin address and the Ethereum address and maybe their Bitcoin address to the same identifier and use that across applications, even if they're like using different blockchains. So you don't kind of want to, we don't want to recreate kind of the problem we have now with the big tech companies with instead big tech blockchains that silo user data, because then we end up in the same kind of problem. And users might also want to have some addresses that are more secure, that store kind of funds on a hardware wallet that might give them access right to a DAO, but they don't want to use that every day to like make comments and stuff on a forum, so they can link two addresses together, one kind of like more hot wallet with less funds and one kind of cold wallet that just gives them access to this DAO community or something like that. We also need this shared global user table to be anti-fragile. And so what that means is when users write to, when applications create data and store that with the user. And so imagine a row in this decentralized user table being name. And so application A might store a name that's just a string, but then application B expects the name to be an object that contains a name and a surname. And now you have a problem, right? Because if a user comes to application A, they will create a name, and then they go to application B, and that will maybe like break the application B and vice versa, right? So we need a way to kind of coordinate and about what data is stored in which way. Otherwise, this system would be like extremely fragile and like wouldn't really work as a means to share data. Another thing is that this needs to be kind of data needs to be like possible to be kept around. So if data is stored on some server, even if that's like completely public, if the application A like relies on application B and application B disappears, then like application A is essentially screwed because they don't have access to the data anymore. So this kind of data needs to live on some kind of like open censorship resistant network. Otherwise it won't work as well. And finally, what we get out of this, when we have this kind of global shared user table, we can start building shared network effects across applications. So I might build an application that has a very neat data model, stores some cool data about the user, and I onboard like 10,000 users. Now, someone else comes along and build another application and sees the data model that I had created was super cool, and they use that, and now they kind of already have 10,000 users to start from that are kind of seamlessly already onboarded into their app, but then they onboard like 100,000 users more. And now my application actually benefits from that, because now I have another like huge amount of users that already kind of are able to use my application without having to go through my onboarding. And this is eventually like, if we start doing this on a higher scale, then essentially any proprietary user database that is smaller than this kind of global shared user table, they would either have to like switch and start using the global table, or kind of start becoming obsolete because their network effects are used within their own kind of limited scope. And this is eventually like how we can, if we keep growing this kind of shared global user table, that's how we can outcompete all of the big tech companies and kind of set the data of users free. So we've been working on a framework on top of Ceramic Network, which is called Self-ID. And this is essentially a way to create this kind of user table that's shared across the entire Web3 stack. But before I dive into that, I want to just give a primer on like how Ceramic works and how data object in Ceramic works. So a Ceramic object is essentially an event log of IPLD objects. So IPLD is a way to represent hash-linked data that's used in IPFS and Filecoin. So a Ceramic stream is created by creating a Genesis commit, which contains some initial information like who's the controller of the stream, and maybe some initial content. And then that can be anchored into a blockchain, and that essentially provides a proof of publication, meaning a timestamp of like when the creation happened. And then the controller of the stream can keep updating the stream by applying signature commits that point back to the previous object using a hash link. And the signature commit basically contains a patch. So if you traverse the entire log, you'll be able to reduce the state of this object. The neat thing is now you don't have to like sync the entire state of a blockchain to get used to the state of like one object on the blockchain. You can just sync the state of like this particular stream to get the state of the stream. So it's kind of really like client friendly. Each stream has an immutable ID, which essentially allows it to allows a user to or like a developer to find what the latest state of a stream is given this identifier, even if however many times it's been changed. It's using DIDs, which is a kind of cross-network blockchain agnostic way of representing a cryptographic identifier. Yeah, and nodes kind of choose which streams in the ceramic network they choose to persist. All right, so I think that's enough to kind of give you a rough idea of like how a particular object in ceramic works, and then of course there are a lot of these objects on ceramic. So let's dive into self-ID. So self-ID can be thought of as a user table built on top of ceramic. It kind of looks like this. So we have the DID, which is the identity of the user, and then you have different rows that contains different data. So here we have like data model 1, 2, 3. So the DID here, you can see we have a did PKH, which is essentially a blockchain address. Did NFT, which is essentially any NFT. The current owner of the NFT is the one that's allowed to like write to this row in the table. 3ID is a DID method that we created because we needed this kind of universal identifier aspect, which I talked about earlier, where we can like link blockchain accounts from different blockchains into like one identifier or multiple addresses into one identifier, so you can bring the data across the different ecosystems in Web3. Each data model in each row here has a data model has a unique identifier. So instead of naming a column with like, name or emoji or whatever, you could, because that will cause conflicts. Each data model gets kind of like a unique hash that is identifies that column. And so if you have two different data models for a name, they would essentially just be two different columns. So here we can see like the first looks like a name, the second column looks like some kind of metadata information about the user, and the third column contains just some encrypted information. So then it's kind of like up to the user to choose which applications are allowed to write and allowed to read this data.
Here we go. Joel should be back in one moment. He might have frozen.
Yeah.
Yep. Okay, guys, we're gonna head to break right now. We've got the Tachyon Filecoin Launchpad Accelerator, the second batch that went through that we're gonna tee up in a few moments. Be right back. Thanks for your patience. Welcome back, everyone. Thanks for your patience again. We're going to change our scheduling a little bit. We're going to do the Tachyon Launchpad Accelerator update for the second batch in a few minutes, just as promised, but we are actually going to be able to go back, and we got Joel again. So we're going to let Joel finish this presentation, and we'll continue with our regularly scheduled program in a few minutes. Joel, welcome back.
Thanks. It seems like internet technology is difficult. All right, so I don't think you lost too much. Yeah, so self ID essentially this user table. So now let's look at a particular row. So in this row, we can see there's an identifier and 3 cells. And so this identifier actually cryptographically controls the row, right? And so it's only that user that's allowed to write to that row, because if an application were the ones that were allowed to write there, they could start siloing data and like keeping users out from like sharing that data with other applications. And so the underlying structure for this in Ceramic, essentially the row is one data object, then each cell in the row that points to each cell in the row. And so each cell in the row is also a data object in Ceramic that can be updated over time. So the user can kind of update and change the data as well. And so if we look at a particular data model, we can see that it contains some metadata information like name, description, something else, and then it contains a data schema. And the data schema is really important because it describes what the structure of data has to be. And if some application tries to write some other type of data doesn't conform to the schema, then that will simply not be allowed. And this kind of really allows for this anti-fragility, which I talked about before, because if you're building an application, you're starting to rely on one data model, you know what data to expect, and there won't be any surprises. So this is like important for us to be able to kind of start sharing data without too much coordination across different projects. All right, so I think finally, kind of once we start having this shared global user table, we onboard a bunch of users and have them use this in various different type of applications. And now we like really grow this and make it into a commons of the internet where we can kind of all building applications share these different users and get synergistic network effects. We really kind of can start rooting out some of the bad practices that have been happening with kind of traditional Web 2 companies, because the only way they can like extract all of that value from the users is that the users don't really have a choice. They can't go from Facebook and go somewhere else because their friends are on Facebook. But once we have this globally shared user data, that won't be possible, because if some company were to try to extract a bunch of value from the user would just go to another application. And so this really forces up like builders to create newsfeed algorithms and things like that are totally value aligned with the user, like with individual people, but also like communities of people. And I think that's really powerful, and like it's really gonna allow us to create a information ecology that's not hurtful in the way that we've seen with social media today. All right, so if you're curious and want to learn more, you can go to self.id to create your row in this table. If you want to build with this and create applications that share the network effects with all of the other applications in Web3, you can go to our blog or our developers website at ceramic.network. And yeah, let's unsilo all of humanity's data.